Welcome to the SEI Podcast series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hi, my name is Suzanne Miller. I'm a principal researcher here at the SEI in the Software Solutions Division. And today I would like to welcome Dr. Eric Heim, a senior research scientist in machine learning at the SEI's Emerging Technology Center. Today we're here to talk about Eric's latest work in artificial intelligence regarding uncertainty quantification. So welcome, Eric. And before we get started, tell us a little bit about sort of why are you here? What is it about the work at the SEI that brought you here? And what is it that you do here sort of on a day-to-day basis?
Sure. Well, first, thank you for having me. So as you mentioned, I'm a machine learning researcher at the SEI, and I characterize my work as focusing on bridging the gap between some of the scientific and mathematical advances from the machine learning research community to sort of the people who are more practitioners, that are people who are actually going to use these in real life systems. So this sort of means like we're taking stuff like from the machine learning department and the computer science department here at CMU, that type of really awesome fundamental research, and trying to bridge the gap between them and people like software engineers, software developers, data scientists, and the people that are developing ML systems that are going to be deployed. And I'll note that this is actually both an art, or not an art, it's a science and an engineering, also probably an art to some degree, to bridge such a gap. So there's actually a lot of work to be done both on the scientific and the engineering side here.
Okay. What brought you here to the SEI instead of doing this somewhere else?
Yeah, so I mean, in my background, I got my PhD at Pitt, so I'm familiar with the area. And then I worked for 2.5 years in the Air Force Research Labs Information Directorate in Rome. So that's how I got my foot into government research, specifically in machine learning. I led a basic and applied research group in machine learning. We wrote papers, applied it to sort of some of the Air Force's problems. We developed systems. And to get back here to the SEI, I sort of wanted to stay within the government research framework, and the SEI is a great place to do that. Also, I'm familiar with the area, so it sort of naturally called me back here to Pittsburgh.
Good. I always like to get a little bit of that from people because we've got lots of listeners that are probably like 5 years behind you, and we want those good people to come to the SEI too.
Absolutely.
So, all right. So we're here to talk about AI. We know that's a priority in the DoD and the federal government, and there's a specific aspect of that called quantifying uncertainty. And so why don't you frame what the boundaries are of that area of research within artificial intelligence for our viewers?
Yeah, so just taking a little bit of a step back, when you sort of talk about machine learning models, a lot of people view them as these things that sort of make predictions about data. And so at a very high level, you can view a machine learning model as one that's trained on some data to make some informed or inference on some input data. So it's going to make some inference or prediction about that data, right? And so this is sort of
and the data that it's getting is not necessarily the data it was trained on, right? That's the uncertainty part.
That's right. Yes, very much so. And so, so like just maybe grounding it a little bit more, like a popular example of this is like image classification, right? And so model accepts some image as input and outputs some label that indicates what's in that image. And so like an example that's probably fairly accessible is if you can train an ML model, given some data, that given some new image of like say a dog, it may be able to predict the breed of that dog, right? So given an image, the output is golden retriever or something like that. And sort of in a practical sense, one of the challenges for these ML models that do this type of task is that the tasks they're trying to do are naturally challenging. And so it's not always going to be the case, and it's actually very much expected that there's certain situations or certain inputs for which the model will be wrong, right?
So if you give it a picture of a cat, we would not expect it to be able to do the job, right?
Right, or even golden retrievers, that you would expect it to do well. It still does it for various reasons. It could output the wrong answer, right? And like just giving a great example of something that's like out of distribution. It doesn't have any idea of a cat because it was never trained on a cat, right? That's a situation where it's going to be wrong. And it's not clear when you're developing and training these systems always that when these models are going to be wrong. Basically, it's not able to predict when it's unlikely to be correct. And so one of the goals of uncertainty quantification is to develop these techniques that are able to, with some degree of, are able to express some degree of uncertainty in their predictions. So I'll say the words uncertainty and conversely confidence, sort of the opposite ends of the spectrum. But basically, the idea is we want these models to be able to express that alongside of these predictions. So not just golden retriever, but golden retriever with some confidence associated, right? And in doing so, so the result at the end, the consumers of those ML predictions, whether there be a human being who's trying to understand what the model is doing or use those inferences, or a software component, they're able to sort of more reliably understand what's going on with these models and be more informed about when they're potentially going to be incorrect.
And I'll just give a very practical example for that in the DoD is in image classification, for example. If I am presenting my model with an image of someone that I think is a threat actor, is a threat, I want to know, okay, before I go and take this guy down and put the handcuffs behind his back, I want to have some idea, is this 30% confidence that this is the person I'm looking for? Or are we in the 90% range? Because I'm probably going to act a little differently between 30% and 90%. So that's the kind of thing that I look at as being necessary about this.
Sure, yeah, I sort of give the toy example, but you're speaking to a point about where in the DoD this lies, and to the point, intelligence analyst tasks or type of ISR type tasks are the most obvious ones, and so you mentioned a great one there. You can think about other intelligence analyst tasks, but are looking at data with the aid of some machine learning model, instead of just taking the black box outputs, like you mentioned. Having some idea of confidence to make better informed decisions is sort of key to a lot of different tasks, both in intelligence analysts, but other potential tasks that you could think about within the DoD.
And there's a multiplier factor here, right? I've got this model that helps me with eyes, and this model that helps me with noses, and this model that helps me with ears. And they all each have some level of confidence. But then when I'm putting them together to try and identify face, then I have another factor in terms of the aggregation, right, of those different elements that may also create, sort of confound the results. So how does uncertainty quantification deal with that aspect that we're not dealing with a single model in many of these complex cases?
Yeah, so what you're speaking to is the fact that oftentimes ML models aren't used in a vacuum. They're used in the context of a larger system, right? And so I think it's, to your point, it's sort of important to understand the various sources of uncertainty, whether it be from multiple models, interpretations of the output, noise at the input, things like that. And so uncertain quantification, writ large, can consider just the individual model case, which is really important to quantify it there. But sort of in the aggregate, how do you eventually take those and make some action based off that inference, what's going on. And so classically speaking, there's the way to think about it in sort of a systems context with your systems engineers to understand how to interpret types of probabilistic events within a system. There's also particular ways you could model the aggregation of the data. So ensembling methods or some specific way of understanding the individual outputs in some structured way to be able to produce some sort of more consolidated estimate of uncertainty, something that certainly is possible.
So what are some of the where's the research in this quantification of uncertainty? Because there's things I know about. There's this probabilistic thinking, kind of thing that sort of floats all the way through everything in AI. Mm-hmm. And that's kind of a foundational aspect of it, is getting people accustomed to probabilistic thinking. But what are the things that are kind of out on the edge that you're working on in the ETC?
Yeah, so it's interesting. So you sort of referenced this idea of that sort of uncertain and probabilistic models are something that the ML community in sort of a fundamental way are very comfortable with. And so dating back, to the roots in statistical machine learning, there's actually a lot of sort of fundamental ways to reason about these models. And I think part of the research now is, how do we get the same foundational understanding of these techniques sort of in the modern machine learning realm, where these are very large, specifically, deep neural network models. And so a lot of the academic literature is trying to take some of the things that you're seeing some of the types of reasoning about simpler models and sort of this deep learning regime. So that's one thing you're talking about. And I think it's important to recognize that where we're working at is sort of trying to take some of the stuff which is, brand new, really a focus now from the academic literature, and trying to make it sort of practical to the people I spoke about before. And so one way of doing that is taking the sort of lens of use cases for which you may want to use uncertainty in your system or to express to a person, and deriving some principled statistical measure of uncertainty for which you can use. So for instance, you may not care about the entire probability output of a model. You may care about a specific subset. I care more about these classes than these classes, or I may care about this probability interval, or I may care more about only the top 3 predictions, not all potential 100 classes I could label something, right? And so taking that and taking the measures of uncertainty which you would evaluate techniques and focusing them on those specific cases, drawing from first statistical principles to defining that particular measure you want to evaluate, is something that we're focusing on. So we're trying to look at ways that we can tell a practitioner for practical guidance purposes, this is, if you care about this type of problem, here's the type of metrics you should care about. And so what we're doing, and some of the work we're doing is sort of defining those metrics and trying to make sure that there's ways to visualize them and understand them better, but also, where's the state of the art relative to those particular lenses? So we are doing an evaluation on this particular, it's an empirical evaluation. We're not going to make like sweeping general proofs about the state of the art, but we're able to show some empirical evidence under those refined cases where you may care about those use cases, about the state of the art in a number of techniques and how they perform.
So I can imagine, just as an example, that in safety, airline safety, right, we've got certain use cases, as you say, that we're more worried about. So, wind shear under clear conditions, right, is one of those things that really, really hard for humans to detect. And so that's a case where, boy, if I had a model that said, if you're seeing these measures coming in from your sensors, you're likely to be dealing with you're going to have some clear wind shear coming up. Is that an example of the kind of thing that you would be focusing your models on, so that you can get that better accuracy, better confidence, but within a smaller bound?
Yeah, I think what you're sort of referring to are sort of, what I think the larger you're speaking. So in the MLP, you're talking about shifts in the data set. So you may your training set, which makes to build the model, maybe focus on a particular set of use cases for which you actually apply it to, like you said, this particularly difficult case, maybe rare or whatever, right? Your model may perform poorly. In those particular cases, you want your uncertainty quantification to be good because your model is likely to be wrong in those cases, right? And so we are doing a little bit of work on focusing on cases, in a specific case, which we can talk more in detail about, something called covariate shift. And so quantifying uncertainty in the presence of covariate shift, meaning the distribution over your instances has somehow fundamentally changed from train until test. That's the type of problem. So like your instances are fundamentally changed in this case. And that's one of the problems we're focusing on. And I think it's, to your point, has many practical use cases within the DoD for which they are going to try to deploy a lot of these AI systems in environments that are going to be changing or have a lot of dynamic elements to them. And so,
or have a lot of noise in them.
Or have a lot of noise, right? And so having your model be able to detect when it's incurring enough change in the environment, whether it be noise or something else, when it's now uncertain, something's changed fundamentally and that now it's uncertain, is a really important practical problem.
So there's a user interface aspect to this I don't know if you guys have dealt with yet, that was just sort of coming to me as we're talking about. If I'm a user and I'm getting accustomed to using these models, and let's put, the pilot situation, I have a whole lot of data coming in, and I use models like this essentially to give me alerts. That's one of the reasons that we use these models. But if I have a bunch of models running and saying, oh, you have a 45% chance of having wind shear in the next 10 minutes. Now you have a 33% chance. Now you have a 65% chance. Are you doing work in terms of understanding how the user interface and how, they call it alert fatigue is one of the things. I can see these models really being a contributor to that alert fatigue if we're not careful about how we present the information from the models.
Yeah, there's actually a lot to unpack there. I think so. Just in general, I think it's important to understand and this is sort of some of the guiding principles of the work, is that how people are using the models and it determines, how you should evaluate them. And so, to your point, I think there's a couple of things. One, the uncertainty in the model can be used to guide when you should provide alerts, right? So if there are stuff, and this is sort of low risk, things you can automate. If the model's super confident in something, right? Maybe you don't bother someone with that, right? Or, right, if you're super confident that some event where you need human intervention, like the type of alerts you care about, those are the ones you show, right? And so if you have a budget for the human beings, the human operator or whatever,
The cognitive load.
right? There's some budget for the cognitive load under somebody, right? You sort of want to prioritize the things you're most confident that they should be viewing, right? And so in some sense, like, if you have this, distribution is so much data coming in for which you may want a human being to look at some of it, and some of it just to assess what's going on. You sort of want to stack it in some way that they're using the best use of time. In some sense, uncertainty quantification is going to help do that, because that provides you some way of doing that. Now, the other thing I think you mentioned that's important is the interaction between the user interface and how the model behaves is really important. So again, sort of from a statistical perspective, calibration is one measure of saying, how likely, is your model outputting the correct probability distribution of your model's predictive probabilities, right? And so one thing, in the most strict sense, you're talking about the entire distribution. How is it predicting over the entire set of class labels it can predict over? But if you're only going to show somebody 3 of the top predictions, right, because the interface only allows for that, maybe you want to evaluate that particular case. And so understanding those probabilities more is something that's guided by things like interfaces or how people are going to interact with the ML system that should be brought down to the evaluation stage of these methods. And so part of the work we're doing is doing that. We're trying to look at how people are using some of these models, and then really trying to go, okay, so what are the metrics and techniques we should be using for those particular cases of interface and other things?
So one of the things that we often have people from our customer community that are listening to these, and I can imagine some of the people that I work with being interested in taking some of the models that they've built and having some evaluation of this if they haven't done it already. Is that something that they can contact the SEI for? Are you looking for interesting models?
Yes. Absolutely.
I kind of thought you might.
Yeah. So I will say the thing that we're doing right now that's sort of most interest is we're doing that evaluation, like I said, but the code base that we're building up is supposed to be somewhat modular in a way that if someone came in with a model, we could swap it in and do this types of evaluation. So when we develop these metrics and ways of assessing these models, we can hopefully be able to quickly spin something up, and given some data set you care about, under some certain conditions and a model you care about, maybe we could potentially just swap this in and do this type of evaluation. So the hope is that when we're done with this work, we're going to have this solid code base and we're going to talk with some people throughout the DoD and the intelligence community about, their models and what they care about taking some of the stuff they care about, putting it in this framework and doing the type of evaluations and giving them that insight into their models about whether they're expressing uncertainty in a way that is acceptable for their tasks. And yeah, so in short, yeah, we have code and we're not afraid to use it for these types of things.
So one of the interesting areas, I'm just curious if you've worked in this area, is the confluence of security and safety, right? Okay. There are certain elements of making something safe that are very common with making something secure. And then there are things that are very separate, in those areas. Do you do that kind of aggregation? Can you look at models from sort of 2 different perspectives and help people understand? It's like, well, yeah, this model, gives you some prediction of the security and the vulnerabilities, but it really isn't helping you with the elements related to safety that are, inherent in this kind of model. Is that something that people might think about?
Yeah, so I think this is a very important topic. I guess my intuition of what I sort of understand what you're talking about relative to the sort of machine learning research is that's sort of like there's this whole swath of research in sort of the adversarial machine learning realm. And so they talk about things like, if you if you're able to be robust against certain attacks, right, you also maybe reveal something about your model, right? And so there is a trade-off there.
Okay.
I think that so largely in the sort of what's hidden in the uncertainty quantification task is that to achieve some of this quantification of uncertainty, you also need to achieve a level of robustness. And so that means you're going to be somewhat robust to the type of security and privacy concerns, but maybe not. And so I think so for this particular project, we're focusing largely on making this sort of the uncertainty quantification bit, but I know that there's certainly work with the SEI and within the academic community, it's sort of more focused on those types of topics. And it's certainly an important thing to think about.
You may be hearing from them when you get a little farther along with this research.
Yeah.
So we've talked about sort of what kinds of effects some of this quantification of uncertainty can have in national security and DoD. Are there any other sort of areas I haven't mentioned that you would want to bring up in terms of positive effects that understanding your level of uncertainty could provide?
Yeah, I think we sort of talked a little bit about some of these. So the ISR community, obviously, there's certain situations where intelligence analysts, where you care about, and I know it's sort of baked into a lot of ISR tasks where an analyst have to provide confidence in the things they infer, right?
Sure.
So certainly that's something that community is very comfortable with, as far as I know. And it's important. It seems very important for their pipeline. Now, there's other parts within the DoD community that I think has been interested in this. One of them is the cyber community. Every time you talk to, I talk to someone who's in cybersecurity and just the cyber domain, they'll tell you that the data comes hard and fast. You're getting so much data, right? And in those particular instances, you have to make decisions very quickly, and then human budget is really at a premium there. And so we talked a little bit about the case where uncertainty can be used to sort of curate what people need to. If people have to have only so much budget, it can be used to curate what they see. And so maybe you're able to automate a large portion of the data flow that's coming to somebody, and then overall your processing throughput is significant because you're able to automate some of that while only showing the hard cases to potentially just a human being. Now, so that's one. I think the other one that's sort of obvious is uncertainty quantification is really important in things for reinforcement learning. And so we know a couple of people within the DoD that care about reinforcement learning. So for things like robotic navigation, right? So that's one. And so exploration of state spaces and reinforcement learning, understanding where you are and what state you're in, and where to explore versus exploit is sort of based on this concept of model uncertainty. And so that's something that's really important. Being able to quantify uncertainty in those cases is sort of vital to do a lot of those sort of navigation type tasks for robotic platforms. And so, so I think those are the ones that come out immediately in my mind. But I think that the more I talk to people, the more people go, "Oh, this is what you should be focusing on." And so I think, honestly,
everybody wants to help.
That's right. Yeah, no, and I'm happy for it, and I'm happy to get that type of feedback. But I think that the point I take away is that this actually is pervasive in a lot of different applications.
So for our viewers that want to learn more about this, more about what you're doing specifically, or just the machine learning and the uncertainty realm in general, are there any SEI specific resources or other resources that you would recommend in terms of a getting started kit, if you will, in this area?
Yeah, so this project, at least on the SEI side, has probably been going for just over 6 months. So we probably don't have a lot out publicly yet. Like I said, we're building code and running experiments. Internally, we have tons of results that we're really hopefully going to show in the next couple of months. So there's almost certainly a project page associated with this on our website. But in terms of publication, sort of look out in the next upcoming months from us, our group.
Maybe the research review.
Yeah, so that's a perfect example. I'm certainly going to present something for that, and we have plenty of results we're really excited to show. But so in terms of outside the SEI though, I think the first place to get your feet wet in this is sort of just a grounding in statistical machine learning literature. It's as boring as it sounds. A lot of the foundations for the type of things we're talking about in this project are based in statistical machine learning, and so. If you're familiar with that, ignore this whole thing, but this whole rant here about this. But grab a textbook about statistical machine learning. They have tons to say about this. Now, if you're on the if you're already there, the next step is to sort of look at the literature from the machine learning community. And so I'm going to forget some people here, but Yarn Gall's group at Oxford does really good Bayesian neural network and other types of quantifying uncertainty within models work. And so that's something that I think is really, really important and something that people can look at. Google has a couple groups that does this type of thing. Off the top of my head, Dustin Tran's group did a paper that was really great, and Jasper Snoek's group also has work on this. And then we're really we have this paper that came out of AI Stats in 2019. We don't. It was published by a group. I'm sort of blanking on where they're from. Uppsala University. It's a 2019 AI Stats paper that they derive these metrics from statistical measures that are really, really useful. And I think if you have a stats background, it's a really nice way to sort of get your mind around some of these calibration and uncertainty quantification techniques. So yeah, that's where I would go. But hopefully, if someone watches this in 6 months from now, from when we're recording it, hopefully you could just sort of Google our group and maybe find some work from us.
Fair enough. No, that's good. I mean, so you're an example of a podcast where we're kind of on the leading edge of the project. Other projects, have been around for a while, have lots of resources, but there are different people that like to hear about both. So you're in the right space.
Yeah.
So what's next for you? What are you working on that you may have some things to tell us about in a few months, just to give people a little tease?
Yeah, I sort of been mentioning we have this calibration evaluation that we're doing. Again, the whole point is to provide some empirical evidence to practitioners about how to understand sort of the landscape of uncertainty quantification and specifically calibration of models. So we're putting the finishing touches on that, and sort of the uniqueness of that work is that we're trying to pose it as here's some principled measures and empirical results based on those measures, sort of posing this as like if you care about this type of uncertainty, here's how you evaluate it. Here's how the current state of the art works on a number of classification problems. And so that's a really good, hopefully, this is the nice first step in a long line of work that we're going to be doing, sort of ground the state of the art in some of this particular lens of viewing uncertainty. And the idea is that that's going to be a jumping off point for both speaking to people within the DoD about, what problems do you care about uncertainty and how do you solve types of techniques? But also, I think what's important in doing that work, we sort of found a number of, research gaps that are really important. Specifically, I talked about, you talked about covariate shift and data set shift with their noise data. That's like one that's I think is really important. But there's also examples, like you said, out of distribution detection, where you have classes you haven't seen before that appear during development or during testing
operations.
Yeah, and so what do you do there? Like, so how do you reason about things in that regime? So there's a lot of fundamental directions.
How do you account for a pandemic descending upon us?
It's actually.
You have a model that predicted that one.
Yeah. It's we have some collaborators actually in the or at least I know some people within the biology or the bioinformatics community, and the covariate shift is so COVID is a very good example of data set shift where suddenly your clinical regime like you had before COVID and during COVID is entirely different. Your models need to update, and so that's like a good example. But there's examples in the DoD context as well. But yeah, that's the type of work. I think there's a number of research gap we've identified that I think is that's on the coming up the next couple of months we're going to work on. And I also need to mention we have two academic collaborators from the machine learning department, Zach Lipton and RT Singh, and they're doing some awesome work, and it's starting to come out now, some of the work they're doing. So certainly look out for, again, Zach Lipton and RT Singh. I don't know if I said that too fast, but so they're going to have to do some awesome work. And so look out for some of the work they're going to be putting in.
Very good. All right. So I want to thank you very much for joining us today, Eric. And this work is fascinating to me. I am not a statistical thinker natively, but have been kind of getting into that groove a little bit with some of the work that I've been doing. So I really appreciate kind of this aspect to it. Us bringing this to sort of everyone, because I think that's actually one of the things that is part of this whole machine learning space is that people that weren't really thinking probabilistically before, there's going to be room, especially maybe not as much in our personal lives, but certainly in our professional lives. I think we're going to be touching a lot of different things with this. And so some of the things you're doing now are going to make it easier later for people to be able to adopt modeling and adopt machine learning as an okay way for us to engage in some of our professional activities. So I want to put that push in for everybody to sort of look at if you took statistics, look at it again, because it's a different way of thinking that we need to be more aware of. So thank you again for joining us. The resources that you spoke about today, we will include in our transcripts for the podcast, so our viewers will be able to get access to all of those. And I want to thank all of our viewers for listening today, and have a wonderful afternoon. Thank you.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.